Okay, pull out your unit circle if you don't have it already, and go ahead and pause the video and try this problem on your own. When you're done, hit play and let's see if we end up in the same spot. All right, remember that 5 over 12, 5 pi over 12 is not on the unit circle. So if you think of 5 pi over 12 as 3 pi over 12 plus 2 pi over 12, you can easily see that that reduces down to pi over 4 plus pi over 6, which are on the unit circle. If you pick something different, that's okay. Just go with it. Let's see if we end up in the same spot. Remember that for the cosine of a sum of angles, so pi over 4 plus pi over 6, that's going to go have the pattern cosine, cosine, sine, sine. So cosine pi over 4, cosine pi over 6, and for cosine you switch the sign, so it's minus sine pi over 4 sine pi over 6. Grabbing those numbers from the unit circle, cosine pi over 4 is root 2 over 2, cosine of pi over 6 is root 3 over 2, minus sine pi over 4 is root 2 over 2, sine pi over 6 is a half. And those familiar numbers come up again, root 6 over 4 minus root 2 over 4, which is also root 6 minus root 2 over 4. If you got that, then you're ready to continue. If not, watch the previous lesson and make sure you're good to go for this next section. All right, the double angle identities. For the double angle identities, there's the easy one, and then there's the more difficult one. Sine of 2a, sine of a double angle is the easiest one because there's only one formula. Sine of 2a is equal to 2 sine a times cosine a. So you just need the sine and the cosine. So take a look at example 4. To find the sine of 2 theta, we have the sine, which is 5 over 13. We need to find the cosine to solve this problem. Now, if you think back of your x, y's, and r's, remember that, first of all, we're in quadrant 2. So if you draw your picture, my angle is in quadrant 2, like so. Remember that sine is going to be y over r. So in that fraction, the y is obviously 5 and the r is 13. What we're missing is x. We need the x to find cosine. So if you remember the equation, r squared is equal to x squared plus y squared. Well, wouldn't you agree that r squared minus y squared is equal to x squared? Just to find the x. We know r is 13, so 13 squared minus 5 squared is equal to x squared. That's 169 minus 25. 169 minus 25 is 144 is equal to x squared. Take the square root. It's plus or minus 12 is x. So you take a look at your picture. Is x going to be a positive number or a negative number? Well, since it's in the left side of the origin, it's going to be the negative 12. So this part is negative 12. Now we need cosine. From the picture, remember that cosine of theta is equal to x over r. Well, our x is negative 12 and the r is 13. Okay, so now we have all the pieces to the formula. Again, what we're looking for is sine 2 theta. And the formula goes 2 sine theta cosine theta, or 2 sine a cosine a. A just stands for angle, so does theta. So plugging in our numbers, we get 2. We're told the sine of theta is 5 over 13, and the cosine of theta is negative 12 over 13. And if you were to multiply that all together, you would get negative 120 over 169. There you go. All right, let's take a look at the more difficult of the two. It's more difficult because there's so many variations on it, but it's essentially they're all the same thing. So cosine squared minus sine squared is one way to do it. if the other one is 2 cosine squared minus 1 and 1 minus 2 cosine squared. Basically, all that's happening is that you're just dividing some form of sine squared or cosine squared. So they are all saying the same thing. You choose the one that has the least work. So for example, if you want to find cosine of 2 theta with that same thing, it's in quadrant 2. So let me redraw that picture. Sine is in quadrant 2. We know it's the 5 and the 13, and we found out from the previous one that it's negative 12. Right? Well, it depends on which one you have. So if you're given the sine already, then it might be useful just to use this formula. You can go ahead and find cosine. We found cosine. You could plug it in to any of the other two formulas, but we just have sine, and that's the formula that just has sine in it, so use that one. Therefore, the cosine of 2 theta is equal to 1 minus 2 sine squared theta. And so it would be 1 minus 2 times 5 over 13 squared. So that'd be 1 minus 2 times 25 over 169. Remember that 1 can have a denominator of 169 just by simply putting 169 over itself. That way we get a common denominator. 2 times 25 is 50 over 169. And then subtracting it just gets you 119 over 169. It's that easy. So yeah, it looks a little bit more complicated because you have a choice. And of course, choices can be difficult. But if you think outside the box and you're clever about it, these are actually easy. Let's take a look at this next example. It's asking us to find sine of 2 theta, given that sine is negative 9 and 41. It's in quadrant 3. So again, it's helpful to draw the picture of where the triangle is. So there's quadrant 3. Sine is negative 9 and 41. Sine is y over r. So negative 9 is over here and 41 is over here. And by working out the Pythagorean theorem again, so r squared equals x squared plus y squared, you're gonna get that x is equal to negative 40. Because we're looking for sine 2 theta, we need to find cosine of theta. So from the picture, we can see that cosine of theta is the x. So negative 40 over the r, which is 41. Therefore, sine 2 theta is going to be 2 sine theta cosine theta. So 2 negative 9 over 41 times negative 40 over 41. And all of that just multiplies down to 720 over 1681. There you go. All right, same thing. This time we're going to find cosine. Again, they gave us the sine. So that version of the formula would be the most useful. So cosine 2 theta is 1 minus 2 sine squared theta. One minus 2 of negative 9 over 41. Square it. Don't forget to do that. Here we go. And let me clear out of this. We need to square negative 9 over 41. So let me show you a useful function in your calculator. If you go alpha y equals, there's the fraction button. So we're just going to go negative 9 over 41. Close it and square it. And 81 over 1681. All right? So 1 minus 2 times 81 over 1681. Okay. Again, the 1 can just be changed to 1681 over 1681 minus 162 over 1681. And if you just simply subtract the 1681, hang on. Okay. If you simply subtract the 162 from 1681, you're going to get 1519 over 1681. Just check to make sure that 1519 divided by 1681 doesn't reduce. And it doesn't. That's it. Okay. Last example. Here we go. Given that, find cosine, given cosine 2 theta is 4 over 9, theta lies in quadrant 4, and also find the sine. All right, here we go. We know that the angle lies in quadrant 4. Oops, wrong quadrant, sorry. Okay, quadrant 4, not quadrant 2. Here we go. Quadrant 4 is over here. We have theta over here. All right. We know that cosine 2 theta is 4 over 9. So the best thing to do, since we're going to find the cosine, is use the formula that has just cosine in it. Plugging it into this formula, cosine 2 theta is equal to 2 cosine squared minus 1. Just plug in the 4 over 9 on this side is equal to 2 cosine squared theta. Add the 1, which is just 9 over 9. 4 over 9 plus 9 over 9 is 13 over 9 is equal to 2 cosine squared theta. Divide 2 on both sides, and you would get 13 over 18 is equal to cosine squared theta. And by simply taking the square root, you would get plus or minus the square root of 13, and the bottom, the square root of 18, is going to be 3 root 2 is equal to cosine theta. As you know, we need to rationalize the denominator, so multiply the top and bottom by root 2. And so the answer would be square root of 26 over 3 times 2 is 6 is cosine theta. The problem is cosine the positive or the negative in the fourth quadrant? Fourth quadrant, the x is positive, so this has to be positive. Okay? Since we know it's cosine, we do have the x, and we also have the r. So on our picture, the x is the square root of 26, and the r is 6. So to find y, 6 squared is equal to root 26 squared plus x squared, or y squared. So 36 is equal to 26 plus y squared. 10 is y squared, so it's plus or minus root 10. And since we're in the fourth quadrant, it has to be the negative, so this has to be negative root 10. Okay? So just based on this, we can easily see that the cosine, I'm using a different color, the cosine at theta is root 26, positive root 26 over 6, and the sine at theta is going to be negative root 10 over 6. I hope that was clear. If it wasn't, go ahead and look up other videos, of course, but you're more than welcome to text me on Remind or email me, and I'll get back to you as soon as I can. Good luck, and I'll see you all again soon.